Hi everyone, myself Dr. M. KAVITHA, Assistant Professor, Department of Mathematics, JGC. Now I talk to you about graph theory. Here I will be discussing some basic definitions in graphs, which is an important for those who are studying graph theory. In this video, I will cover the basic definition of graph, vertex, edge, degree of a vertex, path, circuit, connected and disconnected graphs. And I hope that by the end of this video, you will have a better understanding of graphs. First of all, we see the definition of graph. Here we have one graph. This graph has 4 points that are A, B, C, D. Generally, the definition of graph is a graph consists of a finite non-empty set of points together with a prescribed set of unordered pairs of distinct points. Here, AB is a line that is noted as edge, and joining the vertices A and B. Joining the vertices A and B. Here, an edge is noted as E1 and the edge of BD is E2 and the edge of CD is E3 and CB is E4 and AD is E5 and this loop is E6. So the points A and B are adjacent points. Since the point A and B have a line E1, so A and B are adjacent points, and the point A and its line E1 are incident with each other, as well as E1 incident with B. If two distinct lines E1 and E2 are incident with a common point, then they are adjacent lines. Here we have E1 and E2 have a common point B. So E1 and E2 are adjacent lines or adjacent edges. And in this graph we have one loop. See this loop. This is loop. Loop means this edge. Loop also a edge. This edge beginning and ending with the same vertex. So this is a loop. Next, this is Königsberg bridge problem. This Königsberg bridge problem was an old puzzle concerning the possibility of finding a path. This Königsberg is German city. Now the city is in Russia. In this image, we have the inner city of Königsberg with the river Pregel. There are totally 4 land areas that are A, B, C, D. And which this river Pregel is divided by this land areas. There are totally 7 bridges to travel from one part of the city to another part of the city that are denoted by this. These are the 7 bridges. Now the actual problem is, we start our journey from any one city and across all the 7 bridges at exactly once and return to the same city. This is our problem. So Euler draw a graph with this bridge. The land areas are denoted by the nodes A, B, C, D, and the 7 bridges are the edges of this graph. Now the problem is, start with any one vertex and travel to another city and B, then A. This is not a complete journey. So again start with A, then go to B and D and C and then B to A. This is not a full journey. So if you try more and more times, but we can't meet all the edges exactly once. So it is a unsolved problem. Next, this is a graph represent this map. See, here we have six cities that are noted by W, U, C, K, O, N. Here the edges represent the borders in the map. And then here we have a floor plan, and this graph is a floor plan of this. Here we have 6 galleries are noted as vertices of this graph, and outside is noted by O. This is the floor plan of this. And then now we study the definition of degree. Degree is calculated for a vertex in a graph. Degree is the number of edges incident with that vertex. I repeat once again, the degree of a vertex is the number of edges incident with that vertex. So now we calculate the degree of these 4 vertices. First of all, we take the vertex A. Here A is incident with 2 edges. So the degree of A is 2. The degree of A is 2. And then calculate for B. B has 3 edges. So the degree of B is 3. And for C, 3. And for D, D has the degree 4. Since it incident with 2 edges and it has one loop, so we calculate as 2 degree. Already it has 2, so 2 plus 2, 4. And then next we study the odd degree and even degree. Since it has an odd number or degree, then that vertex is known as odd vertex. If the vertex has even degree, then that vertex is known as even degree, even vertex. See the definition. If the degree of a vertex is an odd number, then the vertex is odd vertex. If the degree of the vertex is an even number, then the vertex is even vertex. Okay, next. Here we have one question. How many odd vertices are there in this graph? See, the degree of A is 4. This is an even number. And the degree of B is 4. So this is also a even vertex. And here we have one isolated vertices, that is, there is no incident edge. So the degree of F is 0. And degree of E is 1. This is the odd number. So E is considered as odd vertex, and here D has 3, so D also odd vertex. Next, come to the point C. C has degree 4, so this is not odd vertex. So in this graph we have two odd degrees. That means two odd vertices that are D and E. Okay. Now see the definition of path. Before study the path, we have to study a walk. A walk is a sequence of adjacent vertices and the edges connecting them. That means in walk, the vertices may be repeat, but in a path, the vertices are distinct. That means the points are distinct in a path. So here we have some examples of path. A, B, C is a path. A to B to C is a path. And start with B, B, C, D. Again we travel this loop and D. This is a path, but here we repeat the vertex D, so it is not a path, this is a walk. And this is not a path since C is a repeat. So this is a walk, not a path. And if you can to find another path, yes. Now start with A to C, C to D and D to B. This is another path. In this way, you can find more paths for this graph. If the path is closed, that means the beginning and ending of the path is same. That means the beginning vertex and ending vertex are same in a path, then that path is known as circuit. That is also known as cycle. So here we have an example, that is A, B, C, A. This is a cycle, or it is also known as circuit. Next, this is a definition for connected graph. In a connected graph, you have a path from one vertex to any other vertex. Then only that graph is known as connected graph. Here we have some examples. This is the first one is a connected graph, and second one also connected, third one also connected. Here if you take any 2 points, there exists a path. Okay, if if does not exist a path from any 2 vertices, that graph is known as disconnected graph. Here we don't have a path from A to C, so this is disconnected graph. And here also we don't have a path from A to B or A to C, any B to D, C to D. We don't have a path, so this is also disconnected. And this graph, we don't have a path to C to E or A to E, any one vertex from this component to this. We don't have a path, so this is also disconnected. So it is clearly conclude that if a connected graph, if a graph have only one component, then it is known as connected graph. If a graph has more than one component, then it will be disconnected graph. Okay. And then now see the definition of bridge. Here, if we remove one edge from a connected graph, then it would be a disconnected graph. Then that edge is known as bridge. Here, the edge AB is bridge. If we remove the edge AB, then this graph would be disconnected. So, this AB edge is known as bridge. Similarly, in this graph, this edge CE, if we remove CE, then this graph has two components. One of this and another one is this. So, this is also a disconnected graph. So, the edge CE is bridge. Here we have three bridges. That means if we remove this one edge, it will be a disconnected graph. So this is bridge, the similar of AB and AD. So if we remove an edge from a connected graph, it would be a disconnected graph. Then that edge is known as bridge. Next, here we have some exercise. That means if you practice this exercise, then it would be better to study the basic concepts of graph before the paper studying graph theory. So it will be very useful to you for studying the paper. Thank you.